Okay, dear subscribers, welcome back to Engineering Mechanics, problem set 2.3, solution to 2.29. Somehow I had missed to upload this, and some of you have requested to upload, so I was to do it last night. I got it delayed. Anyway, let me read out the statement. A pulley A. Look, here is a pulley A. Is supported by two bars. This pulley is supported by two bars. AB is a bar and AC is a bar. So I have shown it with a darker line as compared to this line. Two bars AB and AC which are hinged at point B and C. This bar is connected to this mast at B. This bar AC is connected to this vertical mast at C. To a vertical mast EF. This is EF, your vertical mast. Over a pulley hangs a flexible cable DC. Now, which is the flexible cable? This one. D passing over the pulley G. This is the flexible cable. This one is the cable. AC and AB are two bars. That is to be remembered. By a flexible cable DG which is fastened to the mast at D. The cable is fastened to the mast at point D and carries at the other end G a load. This load named as G, its weight is vertically downward given as 20 kilonewton. And it is not falling down. Neglecting friction in the pulley, determine the forces produced in the bars AB and AC. AB and AC, what are the forces produced? The angles between the various members are as shown in the figure. Now, what is given is Q is equal to your 20 kilonewton. The weight of this vertically downward, it is not falling down. So, since this cable is like a string, so since it is not falling down, the tension force developed in it, let it be S. So, this is holding it back. So, S is equal to Q. So, given Q is equal to 20 kilonewton, AB, AC are two bars, not flexible cables. This is AB and AC, they are not cables, they are bars. That is to be remembered. But DG passing over the pulley, this one, passing over the pulley is a flexible cable. And the tension in it is S, suppose, and it is holding the weight from falling down. The load Q is hanging from the cable DAG. Let S is the axial tension force in the cable. Now the argument is, since Q is not falling down, is in equilibrium, means the net force on it is 0, that is S must be equal to your Q. So the first equation is S is equal to Q. Now what is to be understood here is these 2 points. Bar AB is under expansion. Look at the bar AB. This bar AB, due to this arrangement, this is pulling it down, this weight, trying to pull it down. So this bar AB is under expansion, and the bar AC is under compression. That is to be understood, then it is very simple. Therefore, bar AB is under expansion. Therefore, the tensile force S1 in bar AB is away from the point A. So, S1 for the bar AB, it is away from the point A. Now, similarly, since the bar AC is under compression, the tensile force S2 in AC is towards the point A. The tensile force S2 developed in this bar AC is towards the point A. Now, what is given? This 30 degree is given, this is 30 is given, this 60 is given. And how this is 60? I will calculate and tell you. Then it is very simple. Then here I have drawn a free body diagram. But before I go to the free body diagram, let me explain the various angles here. This point is B, D, C, this is A, and this is Q. So you look here now. Now you look at the diagram, how are the different angles? This angle was given as 60, this was given as 30, this was given as 30, right? So in this triangle ADC 30, 30, 60, so this remaining angle will be 120. Now then at this point, this is a straight line. This is 120, so therefore this is 60. Therefore this is 60. That is what I have shown here. This is 60. Now, again, if you look at the triangle DAB, this is 60, which we just concluded. This was given as 60. Therefore, the remaining angle, this is also 60, because the sum of the three angles in triangle ADB will be 180. Now, look at, so this is the vertical mast. This is the y-axis, because I have drawn here x-axis and y-axis. So this angle is the alternate to this. So therefore this will be 60, because this is parallel to the vertical mast. This is the transversal. Therefore this angle is 60. So at the point A, this angle is 60, this angle is 60. So the remaining from here to here, have to be 60. But this is given as 30. Therefore the remaining angle, this is 30. Now I produce this line to this side and this line to this side. This was given 30. So this is vertically opposite. So this will be 30. Now then this y-axis and this line. This angle is vertically opposite to this. This we just calculated as 30. Therefore this is 30. 30, 30. So we are left with 30 here. So all the angles are known. So now the free body diagram is very simple. Now the free body diagram at point A, by drawing x-axis horizontally like this and y-axis in the direction of Q, the free body diagram is drawn here. So, and the various angle I just explained, this is the free body diagram at point A, Q, and I just explained how S is equal to Q, because the weight is not falling down. This is your S2, this is your S1, this is 30, 60, 60. Now, apply now sigma. Now, this is the free body diagram at A. Now, apply sigma x is equal to 0. Means if you drop a perpendicular here, this one will be your S2 sine 30. And if you drop a perpendicular here, this one from here to here will be your S1 sine 60. And from here, if you drop a perpendicular here, from this point to this point will be S times sine 60, because it is in front of the angle 60. And so two forces are in the negative x-axis, one is along positive x-axis. So the sum of these two must be equal to this for the condition of equilibrium. So that is what I have written. So S2 sine 30, that is this one, is equal to S1 sine 60, that is this one, S1 sine 60, plus S times sine 60, plus S times sine 60. Now let us then apply sigma y is equal to 0. Sigma y is equal to 0. Drop a perpendicular from here on y-axis. This length will be your S times cos 60. And drop a perpendicular from here, this one will be your S1 times cos 60. Drop a perpendicular from here on y-axis, this one will be your S2 cos 30. So S1 cos 60, S2 cos 30, they are in the same direction, that is, and the sum of those two are being opposed by Q plus S times cos 60. So that is what I have written here. So S1 cos 60 plus S2 cos 30 is equal to Q plus S times cos 60. Now then coming back, now from here, put the value of sine 30 is 1 over 2, S1 sine 60 root 3 over 2, S is given was equal to Q 20 kilonewton, sine 60 root 3 over 2. Now, so this becomes S1 root 3 over 2. Now this cancels with this. We are left with 10 times root 3. So, take this 2 to the right hand side. So, it will be multiplied here as well as here. Leaving behind S2 on the left hand side. So, when 2 goes to the right hand side, cancels with this. So, you are left with S1 times root 3 plus 2 into 10, 20 root 3. Let it be equation 3. Similarly, from equation 2 here, S1 remains as S1 cos 60, 1 by 2 plus S2 cos 30, root 3 over 2. Q is given as 20, S is S, cos 60, 1 by 2. So, so now what do you do? Here if you take LCM, the LCM will be 2 and 2 will come to this side, will be multiplied. So when the LCM is 2, on the numerator we are left with S1 plus root 3 times S2, and that 2 which is as LCM is kept in the denominator, goes to this side, it is multiplied, 2 into 20, 40, and 2 into this, 2 to cancel, so we are left with S. And S is same thing as Q, and Q is same thing as 20. So 40 plus 20, that is equal to 60, is your S1 plus root 3 times S2 is your equation 4. Now if you look at equation 3 and equation 4 are two linear equations, only two variables, H1 and S2, so can be solved easily. So I've solved it for you, very simple. So equation 3 and 4 are two linear equations with two variables S1 and S2. Multiply equation 4 by root 3 to get root 3 S1 plus 3 S2 is equal to 60 root 3. That is equation 4. This equation I have multiplied with root 3 to get this. Then below that I write equation 3. And then I subtract. This minus this. So this cancels. 3s2 plus s2 is 4s2 is equal to 60 times root 3 minus 20 plus 20 root 3. So ordinary subtraction. Don't look at this part. Now from here, this becomes 80 root 3. So 4 goes to the other side. So S2 is equal to 4 comes to this side. So 20 root 3. Put the value of root 3, 34.6410 kilonewton. Now similarly, put this value of S2. Put this value of S2 in equation 3. Put this value of S2 to get S1. So from this equation only, so root 3 S1 minus 34.6410 is minus, that is this one. I am putting the value of S2 here in this equation 3 to get it. Now, so S1 is calculated. This goes to the other side. Root 3 comes to this side, is divided. So we are left with minus 0.000000 kilonewton. That is same thing as 0 kilonewton. Means, what is the conclusion? Means this bar AB, which was under expansion, and the axial force H1 on the bar AC is almost 0. Neglected, is almost 0. Neglected.